All right, let's dive in. Today we're tackling something that's been messing with minds for centuries. Zeno's paradoxes. We've got some excerpts from Testo and Colato, and we're ready to get our reality, or at least our understanding of it, kind of shaken up.
It's more than just, reality in general. It's about how we even think about motion, space, and time.
Exactly.
You've got Zeno of Elea, a disciple of Parmenides, and they use these paradoxes to point out, these weird contradictions in our logic.
Yeah.
And Parmenides, well, he believed that motion and change were straight-up illusions. And these paradoxes were, gotta admit, a pretty clever way to back that up.
Clever, yeah, but also kind of a headache. Take Achilles and the tortoise, for instance. It's in the source material. Common sense says Achilles, the fastest dude ever, wins that race, hands down right.
Oh, in the real world, for sure, no question. But Zeno, he's a sly one. He sets up this scenario where the tortoise gets a head start.
Oh, I see where this is going.
And his argument is that every single time Achilles catches up to where the tortoise was, well, guess what? It's already moved ahead a little bit more.
So Achilles is forever chasing, but never quite catching up.
Exactly. He's stuck in this infinite loop of almost but not quite there.
So every step he takes gets him closer, sure. But there's always another step needed and another, and it just keeps going.
And going and going, and that's the point. It's like he's shining a light on a potential problem with how we break down motion into these smaller and smaller pieces. Zeno wasn't literally saying, hey, nobody can outrun a tortoise. He was more like, hey, look at how absurd things get when we assume we can just keep dividing space and time forever without consequences.
So was this all just like some ancient Greek brain teaser? Was he trying to win an argument or something?
It goes deeper than that. Zeno's paradoxes, they were more about exposing the problems, the questions, rather than finding solutions.
Oh,
He
yeah.
was, poking and prodding at the foundation of how we understand the world, showing just how easily our logic can kind of crumble.
Okay, I think I'm starting to wrap my head around it, kind of. But maybe another example will help solidify things.
Yeah,
What about the dichotomy paradox? That one always messed with me.
a classic, for sure. All right, picture this. You want to walk across a room. Simple, right?
Simple enough.
But here's the catch. To do that, you got to first walk halfway there. Then to get to that halfway point, you got to walk half that distance first, and so on and so on.
Wait, so I'm walking half, then a quarter, then an eighth of the distance. It never ends. I'll never actually cross the room.
Bingo. That's exactly what Zeno's getting at. By focusing on how we can keep dividing space, forever, he creates a situation where it seems like any kind of movement is impossible.
This is where my brain starts to short circuit. So if Zeno wasn't saying motion is literally impossible, what was he trying to do with all these paradoxes?
He was trying to show us the limits, right? The limitations of our understanding. Not just, our understanding, but the limits of trying to use logic and reason alone to describe the world.
Like he's saying, hey, there are some truths that are just bigger than logic.
Right. And that brings us to, I think, the real juicy part of all this. How much of what we consider real is shaped by our thinking rather than the way things actually are?
Now that's a thought. Makes you wonder how folks back in Zeno's day reacted to all this. Did they just kind of shrug and say, well, guess we're not going anywhere?
Oh no, not at all. It caused a total stir in the philosophical world. Some folks saw these paradoxes as proof that there has to be a void for things to move into.
Makes sense. You got somewhere to go, right?
Right. And others felt like he was taking a jab at math, saying it can't fully capture the complexities of the world.
So he was kicking off debates about reality, the role of math, all that stuff, way back then.
Oh, absolutely. These debates didn't end with the ancient Greeks. They went on for centuries. Some even thought his work proved that, human reason itself is kind of messed up.
We're just not built to fully grasp the universe and how it works.
That's one way to look at it. And that's why these paradoxes still have so much punch today. It's not just about motion, it's about the limits of what we can actually know.
Okay, yeah, now I'm seeing why this is more than just some ancient history lesson. It's about knowledge itself, how we get it, what it even means.
And it didn't stop there. These paradoxes, they even influenced philosophers like Immanuel Kant, who was also wrestling with the whole nature of space and time thing.
Kant. Wow, so Zeno's ideas were shaping Western thought for centuries to come. This is getting pretty big now.
It gets even bigger, way bigger, when you start to see the connections between Zeno's paradoxes and, get this, Einstein's theory of relativity.
Hold on, Zeno and Einstein. Now that's a curveball I wasn't expecting. Okay, Zeno and Einstein. That's a wild combo. Ancient philosophy meets modern physics. How do those two even connect?
Well, there's this one paradox by Zeno that's not as well known. It's called masses in the stadium. And it kind of touches on this idea of relative motion.
Relative motion.
Yeah, like the speed of something can look different depending on, where you're standing, your perspective.
Ah, so it's like Einstein's theory of relativity, where motion depends on the observer.
Right on. Both Zeno and Einstein were challenging those old school ideas that space and time were like these fixed absolute things.
Okay, I'm following so far. But how does relativity actually play into something like Achilles and the tortoise? That's where things get really tricky.
Well, Einstein's theory tells us that nothing, and I mean nothing, can go faster than the speed of light. It's like a cosmic speed limit. So as Achilles gets closer and closer to that tortoise, those distances he's covering, they get smaller and smaller, right? And the time it takes him to cover those tiny distances, that gets smaller too.
Makes sense. Less ground to cover means less time to do it. But where does the speed of light fit into this?
Because eventually, the time it takes Achilles to cover those super tiny distances becomes so unbelievably small, like almost zero, that it's basically meaningless in the real world, even if Zeno's logic says there's still a tiny gap.
So in Zeno's world, Achilles never mathematically catches up. But in the real world, because of the speed of light, we get a different outcome.
Exactly. It's like the math might say one thing, but physics throws in a wrench and says, hold up, reality's got some rules too.
This is seriously making me question everything.
Yeah.
But before my head explodes, there's one more connection I'm curious about. We talked about Henri Bergson earlier. How did Zeno's work influence him?
Bergson, he was all about the nature of time. And he was a pretty harsh critic of Zeno's whole approach to these paradoxes. He argued that Zeno got things wrong because he just fundamentally misunderstood time itself.
Okay, so what was Bergson's take on time? How did it differ from Zeno's?
Zeno, he was all about breaking motion down into these static points. It's like he treated time as a bunch of frozen snapshots.
I can see how that could lead to problems.
Right. Bergson, on the other hand, was a champion for duration.
Duration. That sounds pretty philosophical. What does it mean exactly?
Think of it this way. Zeno's looking at a film strip, one frame at a time. Each frame is frozen, stopped in time. But when you watch a movie, you experience that flow, that continuous unfolding of events. That's duration.
So Zeno is focused on the individual moments, the frozen bits, and Bergson is more about the flow, the experience.
Precisely. Duration is time as we live it. It's not something you can chop up into little pieces without losing what makes it, well, time.
So Bergson's saying that Zeno's trying to apply like a mechanical view to something that's actually fluid and dynamic.
Exactly. And Bergson went even further. He said that to really understand this flow, this duration, you need more than just logic and intellect. You need intuition. It's like a direct connection to reality that goes beyond just breaking things down into smaller and smaller pieces.
So he's saying that our brains, our logical way of thinking, can't fully grasp time, maybe even reality itself, that we need a different way of knowing.
That was the core of Bergson's argument, and here's where things get truly wild. These questions about reality, perception, they pop up in one of the most mind-boggling fields of science today, quantum physics.
Quantum physics. Are you saying these ancient Greek paradoxes have something to do with like atoms and subatomic particles?
It's all about challenging our assumptions about how the world works. For instance, in quantum mechanics, there's something called the measurement problem.
The measurement problem.
It's this idea that when you try to measure something in the quantum world, the act of observing it actually changes it.
Wait, so if you try to measure where, say, an electron is, you're actually messing with its position just by looking at it.
It's more complicated than that, but you're getting the gist. It's similar to how in Achilles and the tortoise, breaking motion down into tiny bits creates this illusion that Achilles can't catch up.
Okay, my head is spinning a little.
Both scenarios show how the act of observation can actually become part of the experiment itself, and that really blurs the lines between the observer and the observed.
Okay, that's pretty mind-blowing already. But quantum physics gets even weirder, right? I've heard about particles existing in multiple states at once, things just popping in and out of existence. How does that connect back to Zeno?
Zeno's paradoxes, they force us to confront the limits of our senses, our intuition about what's real. Quantum physics takes this a step further. It suggests that reality, at its core, is inherently uncertain, unpredictable.
So Zeno was basically dealing with the weirdness of reality way before we even knew how weird it could be.
Exactly. The idea that a particle can be in multiple places at once, or this concept of quantum entanglement, where two particles are linked instantaneously no matter how far apart they are. It's all very counterintuitive. It goes against our everyday experience.
It's like our brains are wired to see things a certain way, but then quantum physics comes along and throws the rule book out the window.
Exactly. And that's where Zeno's paradoxes are so valuable. They train us to question our assumptions, concepts, to recognize that our logic, our gut feelings, they might not always be the best guide to how the universe really works.
So even though these paradoxes are thousands of years old, they're still relevant because they help us wrap our heads around the strangeness of modern physics.
They teach us to be open to the possibility that the universe is far stranger, far more complex than we could ever imagine. And that's a powerful lesson, whether you're pondering the nature of motion or diving into the mysteries of quantum mechanics.
This has been an amazing journey. We've gone from ancient Greek philosophy to the cutting edge of science, and it all ties back to these fundamental questions about how we understand the world.
It really shows how powerful Zeno's ideas were. He wasn't just playing games with logic, he was forcing us to question the very foundation of our understanding.
And remember the arrow paradox,
Yeah.
where Zeno argues that a moving arrow is actually at rest.
Oh yeah, that one. It's a real head scratcher.
Well, it turns out that even that seemingly absurd idea finds an echo in the bizarre world of quantum physics. All right, let's unpack that arrow paradox a bit more. How can a moving arrow be at rest? My brain's still trying to process that one.
So Zeno's argument, it goes like this. At any given instant, like a snapshot in time, the arrow is occupying one specific point in space.
Okay, I'm with you so far.
And since it's not moving within that single instant, he says it's essentially at rest. And if it's at rest in every instant, well, how can it be moving overall?
Yeah, that's the part that makes my head spin. But you said quantum physics has something to say about this too.
It does, and it gets pretty wild. Quantum physics introduces this concept called wave-particle duality. It says that particles can act like, well, both waves and particles.
Hold on. So an electron, for instance, can be a tiny speck of matter in a wave, like a ripple in a pond.
Exactly. It's not something we can easily picture based on our everyday experiences, but it means that instead of thinking of that arrow as a solid object traveling on a fixed path, we can think of it as having a wave function that spreads out over space.
So more like a ripple than an arrow. I'm trying to visualize this.
That's a great way to think about it. That wave function, it represents all the different positions the arrow could be in at any given time. It's only when we actually try to measure where it is that the wave function collapses and the arrow chooses a specific spot.
So it's like, until we look at it, the arrow is in this hazy cloud of possibilities, kind of like it's in multiple places at once.
In a way, yeah. It's not that it's physically in multiple spots, but rather that its position is undefined until we measure it. And that act of measuring, it forces it to pick a spot.
Okay, so how does all this tie back to the arrow paradox?
Well, if we look at it from this quantum angle, we can see that even when the arrow seems frozen in that single instant, like Zeno describes, its wave function is still doing its thing, it's spreading out.
I see.
So it's never truly at rest, even in that tiny sliver of time.
So deep down, the arrow is always in motion, even if we can't directly see it.
Exactly. It's almost like Zeno, without knowing it, was hinting at this idea that reality, at its most fundamental level, plays by a different set of rules than we're used to.
So we've got all these mind-blowing links between ancient philosophy and modern physics. But didn't you mention earlier that there's also a more straightforward mathematical way to resolve Zeno's paradoxes? Something about calculus?
Right. Calculus, it was developed by Newton and Leibniz back in the 17th century, and it gives us the tools to deal with those concepts of infinity and infinitely small things that were giving Zeno so much trouble.
I'll admit, math isn't my strongest suit. Could you break down how calculus solves these paradoxes?
The key is this idea of limits. Calculus lets us calculate the sum of an infinite series, even if the individual pieces in that series are getting infinitely tiny.
So, like in that dichotomy paradox where we kept halving the distance forever, calculus shows us that all those infinite halves can actually add up to a finite number. I can actually reach the other side of the room.
Exactly. Calculus gives us a way to understand how we can have motion and change, even if space and time could theoretically be divided forever.
So does that mean Zeno's paradoxes were basically solved? Are they just a historical curiosity now?
Not at all. While calculus handles the math side of things beautifully, it doesn't erase the philosophical questions Zeno raised. They still make us think about space, time, and the limits of our understanding in a really profound way.
It's like Zeno was saying, sure, you can explain it with equations, but you still haven't fully grasped the mystery of it all.
That's a great way to put it. And that's why his work is still so relevant. It pushes us to look beyond the surface, to be open to the possibility that the universe might be much stranger than we initially thought.
This entire deep dive has been an incredible journey. Ancient philosophy, modern physics, even a little calculus thrown in. And it all goes back to these deceptively simple thought experiments.
It's a real testament to the enduring power of Zeno's ideas. He wasn't just trying to stump us with riddles, he was inviting us to question the very foundations of how we make sense of the world.
So what's the big takeaway here? What can we learn from all this mind-bending exploration of Zeno's legacy?
I think the most important thing is that Zeno's paradoxes weren't just about motion. They were about recognizing the limits of our thinking, the ways we perceive reality, and this amazing back and forth between philosophy and science.
He was encouraging us to look deeper, to challenge our assumptions, to be okay with the fact that there are mysteries in the universe we might never fully explain.
And if Zeno could see how far we've come, all the discoveries we've made, I think he'd be just as fascinated by quantum physics and our modern view of the cosmos as we are by his ancient paradoxes.
Now that's a conversation I'd love to be a fly on the wall for. Zeno debating the finer points of wave-particle duality with a quantum physicist.
It would be a lively debate for sure.
Well, on that note, I think we've reached the end of our deep dive into Zeno's paradoxes. But I have a feeling this is just the beginning of our exploration of these timeless questions.
The journey of discovery never really ends, does it?
For all of you listening, if you're feeling inspired to delve deeper into the world of Zeno and all this mind-bending stuff, we've got some great resources linked in the show notes.
Go explore. See what sparks your curiosity.
Until next time, keep those minds curious and keep exploring the depths of knowledge.